Hello, in this video we are continuing our discussion of section 6.3. We are talking about trigonometric substitutions. Specifically, we are talking about how to use completing the square with trig substitutions to help us evaluate integrals. In example 4, we've been asked what would be an appropriate trig substitution for the following integrals. So in part A, we have the integral of 1 over the 1 over the quantity, x squared minus 2x plus 2, and all of that being squared. Now, this is a problem that we would use a trig substitution on, but it's not terribly obvious because we don't obviously have something squared plus a constant squared. But we can use completing the square to help us get that correct form to use a trig substitution. So for part A, we are going to complete the square on x squared minus 2x plus 2. The reason why we are doing this on x squared plus 2x plus 2 is because of the fact that this is what's being raised to our power. So for completing the square, I want to keep all of my x terms at the beginning, and then my constant term I'm going to write towards the end. I'm going to complete the square on the x terms. The way that I do that is I take this value, -2, I divide it by 2, and then I square it. So that is going to give me a -1 squared, which is 1, so I'm going to add 1. Algebraically, you can't just add something to an expression. You also have to subtract the same value to cancel stuff out, so you're not actually changing anything. So 2 minus 1 is going to end up giving us 1. X squared minus 2x plus 1 factors to x minus 1 times x minus 1, which is x minus 1 squared. So we have then x minus 1 squared plus 1. So our integral then would be the integral of 1 over x squared minus 2x plus 2 all squared dx. We could write that as the integral of 1 over x minus 1 squared, minus 1 squared plus 1, all of that being squared dx. So now we have the form x squared plus a squared. Here you have x equals a tangent theta. We don't have just an x, we have an x minus 1. So the trig substitution that we're going to do in this case would be x minus 1 is equal to a, which is 1, times tangent theta. So I'm not going to continue with this because the example hasn't asked for it. But if you use the substitution x minus 1 equals the tangent of theta, you can differentiate, you can plug in, simplify everything, go through it the same as you would with any trig substitution problem. So the final answer for part A is just this substitution, x minus 1 is equal to the tangent of theta. Now for part B, we are going to do something similar. Part B, we have the integral of x squared over 3 plus 4x minus 4x squared to the 3/2 dx. Let me make sure that is the same. Yes. Okay. So again, we're going to complete the square. On the part in the denominator that's in the parentheses, 3 plus 4x minus 4x squared, because that's our complicated expression that's being raised to a power. So in this case, I'm going to rearrange the terms first, -4x squared plus 4x plus 3. Now the x terms, I don't really want this -4 in front. It doesn't work with the easy process that we used in the previous example to complete the square. So the first thing I'm going to do is factor in -4 out of all of the x terms. So this means we're going to have an x squared and a minus x. I'm going to leave a little bit of room there in the parentheses because that's where I'm going to complete the square. And I'm going to leave my constant outside of that. Now, completing the square, I take this value, negative 1. I divide it by 2 and I square it to get a 1/4. So I'm going to add 1/4 in here. I need to cancel it out. In this case, I'm not just going to subtract a 1/4 because I have a 1/4 being multiplied by negative 4. So if you take those two into account, I'm actually subtracting 1, which means that I need to cancel it out by adding 1. Okay, so then we have negative 4 times x squared minus x plus 1/4. Then we'll have plus 4 out here. This factors to x minus 1/2 squared. Notice I've gone back to the negative 1/2 value there, okay? But you can do the factoring if you'd like. So I can rewrite this as 4 minus 4 times x minus 1/2 squared. Now for the integral, we're going to have x squared over everything in the denominator gets rewritten as 4 minus 4 x minus 1/2 squared. All of that is being raised to the 3/2 power. So we have a constant being squared. This is some function of x, so it's the a squared minus x squared form, which means that you're going to have a sine function, but you need to figure out what the sine, what else you're going to have in there. So 4 minus 4 times x minus 1/2 squared. I can write that as 2 squared minus 2 times x minus 1/2 all squared. And this can be distributed to be 2x minus 1. So I have 2 squared minus 2x minus 1 squared, and that makes it a little bit easier to see what our substitution is going to be. So we will pick the substitution 2x minus 1 equals 2 sine of theta. And that is our final answer for this problem.